Hey, today I'll be showing you how to use protastructure 2018 in modeling your simple structure, running your analysis, the fundamental things you need to understand while running your structure, the basic setting, and the ideology, the analysis, the consideration in figuring out your basic model. Today we will be designing a simple two-story building. My name is Adasi Junel and I am your instructor. Doing this, we're going to launch our protastructure 18, and we're going to wait for this to boot. All right. So you can see on our protastructure, these are the previous, file we've already done and our data. So in this regard, we're going to select our new project. So in getting a new project, you're going to click on this icon, new project. So we're going to type on the name, let's say tooth. Let's leave it to be tooth on tooth. So we click OK, and it's going to take us on our code reference. So we have a lot of code, reference here, but let's go on error code. Let's go on our basic UK British code. Some other video will be exploring each of these code and how you can use them. So in this one, we're going to click on UK this code and we're going to import. So wait a while for it to import. All right, all right. So when it finally import opens, so this is what we're going to see. This is the interface of protastructure 2018. So this is what you're going to see. So for you to do this, we are going to import the drawing into this interface so we can start our structural modeling. So for you to do that, you can click on file. If you click on file, you can go to export file, export file, and it says export file, sorry, import file. And when you click on import file, you're going to see this, box saying load drawing model, external reference drawing, import from Revit. So what we're going to do, we're going to click external reference drawing. So if you don't want to go with this approach, you can also click on this. This is the icon, So if you click on this, it's going to take us on, there's the referencing. So looking at the referencing, we have the load and we have the, you know, the import member, and we're going to see the display color, and you're going to see the PDF color. This is the color that is coming from, the AutoCAD. So let's go on, click on load. So you click on load, you wait for it to pop up. So you go to where you save the document. We save the document on our desktop. So we'll click on tutorial and we'll say open. Click on open. So when you click open, it's going to take you on the unit, you need to specify the unit. Since our unit is in millimeter, let's click millimeter. So clicking millimeter is going to, pop up the design, bringing the design. You can see the design that we'll draft. So in this area, since we have the design here, we are going to, import the member. Click on import for you to import the grid member as well as, the column member. Take note, if, for example, you did not save to the layer of, maybe you have your grid member, you have your grid layer, like formerly we have S grid, you see. So any layer you added, any layer you have, one will have S grid identity. So if we use this to create our grid, then we are going to make sure that this is turned on. So this is the layer we choose here. But since we created our layer, we are going to say grid, so that it's going to use the grid to, to import it. It's going to import it by grid. So in this regard, we just say close. So if you say close, you can see from that you close this order. You see, finally we have import our members. So if you take a look at this, the members has finally been imported. All our columns that was done on the GA, you can see the positioning of our columns. You see, so what we are going to do at this point is to start putting our beams, that's why I enjoy protastructure, because it's safe and it's fast. So at this point, we're going to start putting our beams at the right position where we need the beam to be at the wall, no, the wall area. So you're going to put your beam. It's easy for you to put your beam. That's why you import this drawing so that your beam will be on the wall area for you to trace them, and you putting your beam, inserting your beam at those area. So finally, what we're going to do this, so let's start by putting our beam. So you click your beams, click on the beam icon. So you wait a while for the beam to display. So this is our beam property. So the beam property, in this beam property, you specify the width of your beam, as well as the depth of the beam. So in this regard, we'll be using 225 because that's the wall thickness on the architectural drawing. So on the height, we're going to use 450. We're going to be using 450 to design this. Why am I using 450? Because of the close range of my columns and for me to ensure safety costs, because I'm sure that this depth is going to be sufficient to carry this small structural model, depending because of the closer distance. There's another thing. When your distance between two columns becomes so much apart, then you are increasing the chance of you having a high tensile member, a higher reinforcement on your beam. But when your column are closely spaced, then you have, to have you have a slim chance of having a higher reinforcement in your beam detail by the time the output result will be out. So we harden this will be your 3D. So we should not be bothered about this. We should just put our height, and we should look at this. There's a little box here telling you, do you want the beam to be at the other face of the grid, or do you want it to be at the center, or do you want it to be in the other outer face? So we're going to say center. It should be aligned at center. And this is showing you for the curve, we're not creating a curve beam. So, and we're not hinging now. At the end of the day, we'll be exploring this. So let's say update, and let's start, you can do this, insert your beam by clicking one point, and you can drag, since we are having our beam along this area, all across this area, we're going to go to the last point and we'll click. So we come the same thing, we'll come here, we click, we'll go to this other one, since we are having, we're taking on the edge. So half this, and we're going to go straight up, down this area and down here. That's what we're going to do. For you to terminate this, for you to be able to click another one, you click on your escape and you click on the next point, you go. So that's the termination point. You click on escape, you click on the next point, and you click on escape. You click on escape just once, not twice. You click on escape just once. So click on the next point and we'll drag your cursor to the next point and you click. You go to the next one, you're doing your left click, not right click. You left click on it, you drag to the next point and you click. As simple as that. Your beam will be traced. So at this point, we'll have another beam here. You can see from the wall down. So you click and we go. You escape. So we have another, beam here. So click here and we click, we escape. Since this is what I'm talking about, since this beam is too, is too wide for we to have, our slab here because of deflection, this is above 30 square meter. This is about 40.6 like we did from our GA. So we're going to cut a beam across this. So cutting a beam is going to tell you, show up, pop up, text asking you if you want to cut the beam across. It's now going to form a secondary beam. You say yes. So in that regard, it's now going to separate, the beam. It's now going to separate this beam from this beam, making it, a two layer of the beam, a two span beam, you can see, and this beam is resting on this, so you take note of this. When you see something like this on site, you know that can easily identify by tracing this, that this beam is resting on this. So this beam here, this particular one should be on top of this. So you first of all construct this beam before you take this beam, before you put this beam on it. That is the simple, explanation of what this actually means. So this is the design phase, but I'm trying to add, what this really means on the site. So we'll be looking at some of those things as time permit. So you can see so easily we've set up our basic, so you can escape, press your escape button twice now. You can see that we've set up the beam area, so easily because we have the important document of the wall that we can easily trace and make this a, a easy one. So next we're going to go to the slab because we want to insert our slab right now. So if we have our slab, we're going to check what will be the thickness of the slab. Now we are designing a solid slab. Take note of that. We are designing a solid slab. So you designing a solid slab, you need to, I recommend you go with 150 millimeter depth for the solid slab. So we'll be taking 150 millimeter, and our concrete cover we can leave it, the 25 millimeter. So we're going to look at the self weight of the structure. This is the self weight of, you know the self weight of the slab. So what we are going to do now is to add the dead load and the imposed load. This dead load now talks about the finishing, the finishing stress, like things like the ties and the ties and some other finishes. So in this regard, let's just put 1 point, 2 for this, and we'll go to the imposed load. On imposed load, you can see there are several specifications for the imposed load, from depending on where you're designed, from code, depending on where you're designed, we have a residential building, we have a general domestic use, a residential commercial area with limited use, a room for domestic, you can see on and the toilet area. So we're going to select based on what you are designing. So in this regard, let's take general domestic use. So if you click on general domestic use, you can see the code, specified here. So in this regard, we can go back to general and we can start inserting. The insertion, they have different type of insertion. The insertion type, we can take by axis, which means you can take your axis region and insert your slab. So this is the beam, this is the beam, region. This is the pickup point where you can pick various points and insert your slab, and this is pick axis rather, and this is the pickup point where you can pick your point, and in this axis you can pick the axis around the perimeter. You can see you can decide to pick this axis. If we go close, you can pick this axis, you can pick this axis, or you can pick the next axis, you can pick the next axis, and you go back to this axis. You can see the introduction. You see, so for pick point, you can pick various points. But for us to make this simple, we can go by beam so that you can snap the beam region. So we click on this where we need our beam to go to insert. So click on this, click on this, click on this, and all this area. So looking at this area, you can see that we have our staircase here. We have our staircase here. This staircase is quite below, and this beam is above this staircase. So there is no way they are going to cluster. So that's why I cross this beam here. That's why I cross to this point, so that I can have my beam, segment here. So I can easily insert my slab here. But in this area, I'm supposed to have a slab here because this staircase is only at this region. You can see the staircase point telling you that this area is still on the plan. This area is not void. But if you still want to design this area based on different design, you can still say, okay, you want to make this area a different one. So in this regard, since this is not, considered, we didn't consider this. I left this for a purpose so that we can correct this. Maybe if there's any, maybe you forgot something, you forget some, your this, you don't need to cancel maybe you forgot some things before getting to your protastructure, you don't need to cancel it and restart again. All you need to do is to go back to the architectural plan and take this dimension. If you get this dimension, like you get this dimension maybe from here down to this grid, from this grid to this one, and from here down to this other grid where we have a finish. What we're going to do is to offset the grid. So if you offset the grid, then we're going to use the offset, we're going to use the grid axis or the pickup point, every other one to offset the slab. So we're going to go back to the AutoCAD for us to be able to get this dimension. So here in AutoCAD, you can see, let's take the dimension. We take the dimension from this outer face down to the grid line, and you can see, and this other area. Since we have another grid here, since we have a grid G at that point, let's offset grid G. Let's offset grid G from this area. You can see, okay, this is 110 and 1563. So we're going to offset this distance. Sorry, let's click on this. We did a mistake here. So coming back, we are going to click on this grid G, and once it's active, we're going to say offset. So checking our offset distance, this is 110, right? You click. So here in product structure, you are still also going to consider this distance. So you click on this axis, because from this axis to this point, we have 1.5. You click on the axis, you're going to type in distance, you know. So I'm going to say enter. So that is it. And another way, we're going to escape. I'm going to click on this too. Click on this other, and as this, I will click on the offset. We are trying to offset this to get this, to get this, finishing, to get this distance. So you can put up, can slide, you can see the angle showing us there. You can click on that angle. It's the same, the same length. So with that, we can escape. So in this regard, we can also add the slab. So we can click on this and check the properties, since we have similar properties to this, but we're going to change the insertion point to pick axis. So we're going to pick our axis. So we're going to pick the axis this axis will pick this, and we'll go on this. So we can get the boundary, and we'll get the one we just offset newly, and we'll click this. So you can see this, and we'll click, and we'll go by escape. You press your escape, so you can see that it's going to take this portion of the slab, and this is acting like a cantilever to the beam, stressing it this way. So when we're doing our detail, we're going to explore how you can take this, into this. But since we're doing a model, let's focus on the model, and the analysis will run on the beam. So in this regard, you can see that we have achieved this step, the staircase opening, so this is how you're going to do it. There's another thing you need to also consider. Now, looking at this area, from the ground floor, we have an entrance porch at this area. But on the first floor, there is an opening. So in this regard, let's go to the architectural floor and look at it very, very well. This is the more reason why I said you need to understand the architectural plan before you do anything. So let's go back to the AutoCAD. You can view here, you can see the entrance porch is open here, and these are flower pots. There's a flower pot around the area, and another here. So look at the entrance port where we have here. Look at here. So on the first floor, this is now a sit out. You can see this is now a sit out on the first floor, and on the other floor is now a sit out, which means there's a balcony there. Whereas on the ground floor is open. So what we're going to do, it means that we're going to introduce a beam here to support this balcony. We're going to introduce it to support this balcony. So in doing this, let's go back to the product structure. So here in the product structure, we are going to highlight the same beam and take the same property because we want to introduce a beam here. There will be a beam here taking this. Otherwise, if you don't want to do this, you don't want to create this beam along this area, there could be other things you need to do depending on the design. Depending on the design. Now let's take a good look at this on the 3D. Let's take a good look at this. So on the 3D, you click on this, you right click. So you can see this. You can see there could be a reason, um there could be a desire from the architect that he wants a slab to be around this area. He don't want a deep finish like this. So and when you looking at the deep finish, it's looking somehow odd. So I think since this slab is a very simple one and a little one, let's introduce a slab there because it can also take care of it. Let's introduce the slab. So we go back to our plan and we take this off. We take this off. Or what we do is we introduce a little, we make it fit in. Make it fit in. And we update. Checking this. So this we are reducing the depth of this beam. We're trying to reduce the depth of this beam such that this beam will flow with the slab we are going to insert. Will flow with the slab we are going to insert. That is what I mean. You can see they are having a smaller shape beam so that when we insert our slab, it's going to take a uniform area at that area. Don't forget that this is a wall area. This is where we have our block wall. So by the time this block wall is laid, this area will be covered. So the same thing here. So if you're going to introduce this same depth of beam here, somehow it might look ugly. So it is very, very preferred for you to keep it this simple. Since we do this, so you can decide to put your slab or try to convert this beam to be an internal beam. So this is what I did by making this beam an internal beam. So let's go back to insert our slab. So coming here, we'll take our bizarre property, click on the slab, go to property. So we're going to click here, going to make sure we turn it. It's not showing active because it is on, peak axis. So we'll click on the beam so that you can snap the beam region and we'll click on the beam region. So you can see we successfully activated. Then we can now close. We can now close. And at this point, we've successfully achieved our beam model, our slab model, and our column. We are done with the model for this level. So there's another thing I want us to consider because there will be a wall load, a load on this beam. So for we to do that, we are going to load this beam with the wall, to see the reaction, so that the reaction of the load will be valid, will be transferred into this beam while we are running analysis. So what you do is you click one of the beam, then you right click, you go to edit beam wall load. Look at it here, edit beam wall load. You click on edit beam wall load. At edit beam wall load, you come to your unit weight of the wall unit weight. So your wall unit weight is 3.74. This is for your 9 inches block. Since we are considering our 9 inches block, our 9 inches wall, we are going to consider using this unit weight for our 9 inches wall. So we are going to specify the height. So because of this beam that I drop, I'm going to take a height of 3.3 meter. All this is in meter. You can see it's in meter. So we can now go by specifying the thickness of the wall. So thickness of the wall in meter will be 0.225. You see is 0.225. So in this, this is now the dead load. So this is dead load in such a way that you have your cantilever, you're having your cantilever, your free end cantilever. You're going to use this load to, act to calculate the load to add, making it converting it to be a point load to load it, so that you're going to run such calculations. So in that, we are not designing the cantilever here. So we're going to do with this, do that. So you're going to click OK, So you click OK, you can see the beam. So for you to make this faster and easy, you're just going to, you know, right click, and you're going to say copy beam wall load. You copy the beam wall load, you go to the first, you come here to the beam. Regardless, this is the beam, this is this beam too. So what we're going to do, we're going to click on the first beam, then you scroll down to where you have the last beam. So you press your shift button, hold your shift button down while you click on the last beam. It's going to highlight all of them, including the one that has already been loaded already. So you're going to right click, move your cursor down here, and you're going to say paste copied beam wall load. Now, if you click this, it's going to show you this icon telling you that this other guy has already been loaded. Did you want to replace such load again? Very simple. You say what? Yes. So when you say yes, as simple as that, you can see it has already generated all the wall load, on the beam. It has generated the wall load on the beam. You can now see the wall. This is the wall load on our structure. So right away, what we're going to do now is to insert the numbers of story, because we are done with the floor modeling. We are done with the floor modeling. So what we have here is the same thing that is going to on the first floor, the second floor, and up as we go. So let's go back to our plan. This is the plan. So in doing this, since we want to generate this story and insert more story, for we to get other floors, we need to go to the building layer. So you click on the building layer, scroll down to where you have your insert story. So you click on insert story. So for you to insert story now, you need to pay attention. If for a reason you are designing a story building, then you're going to take it as two, one being the first floor and the second being the roof floor. So now we are designing a two-story building. We are going to add three. The first being the first floor, the second being the second floor, and the roof. So this is what we're going to do. We're going to add what? Three. We should insert three stories to this. So we can achieve the first floor, the second floor, and our roof. So click OK. So you can see showing the pop. Just say yes, you want to continue. And it's going to continue to show you this. So it's going to transfer. Now look at your element. There is a button here. This is your story zero, meaning your foundation level. This is your floor, meaning your first floor level, the second floor level, and this three, meaning your roof. Telling you that so you have a bubble here. That is, this is the only area where you have your element. That here, which is the second one we just inserted, there is nothing, as well as the third. There's nothing here. So what we're going to do is to move down to the first one, that we're going to generate this down to other floors, since the building are the same thing. Since we have the same similar, what we have on the ground floor is what we have above. So we just click this and we go to generate. Let's generate what we have on the first floor to other floor. You click this. So you're going to look at what do you need to generate to the next floor. You can see the member type generated. You want to generate your columns, the walls, the beams, the bracing. You want to generate the slabs, loads, the slab, the ridge slab, and the case may be the grout, and the case may be. So since we want to take this to the other floor, we'll be having slab at the second floor. So what we're going to do is to click on this and we'll get this. So in doing this, you're going to click OK. Once you click OK, once it has generated, you're going to see process completed. So once you click this and you click this floor, so on the two, you're going to say OK. So if you click OK, you can see the bubble as shown up here, telling you that you have successfully generated what you have on this floor down here. The same thing here. So you click on the next one. Since what we have on this other second floor, what we have on the first floor, what we generated to the second is what we're transmitting. We're going to do the same process. Click on this one. But on this last floor, I don't want to generate the slab. You can see, I don't want to generate the slab because I don't want the slab to take, it's not, I'm not designing a slab in the roof. I'm designing I'm designing a normal roof, where we are going to have our zinc sheet. So we're going to have a beam, going to have a roof beam. So where we're going to have our wall plate and all the roofing sheet and all the king posts will be tied to. So in that regard, what we're going to do is to untick the slab members here. We're going to untick all of this, so we're going to have only the columns and the wall. We're not designing the wall, and we're not designing the beam, and we're not designing the wall and the bracing. We're only looking at the columns at this area. So regardless, you just say okay, click OK, and the process will be completed. Once the process is completed, we are now going to say close. So you can see that we have successfully generated from the first floor to the second, and now we are on the last floor. So let's try to see what we've got, what we've done so far from the 3D. So you can see this is what we've got so far. But there is something. Now, this floor, this roof beam, no, since we have the beam here and we have our we have the wall loads, we have the load on the beam. So it generates throughout the floor, telling us that there is a load on this beam. But you know that we're not introducing a wall here. So we're going to take off this wall, we're going to take off this wall load. So in taking off the wall load, it's as simple as you know, clicking this beam, you highlight this, you go to the last one, you hold on your shift, you click, just highlight all the load, then you right click and you will say delete beam wall load, delete beam wall load. If you click this, say yes, it's going to take them off. So you're taking them off, you have to look at it. If you look at the beam now, it's now looking okay, but not so okay, because if you zoom close, you can see that this other beam wall is now exceeding our height, our building height. So in doing this, we now have to go and edit our building height such that it can match the level of the wall. So in doing this, let's go back to the building, you know, the building set out. Building set out, we'll go to edit story, so that we're going to edit these floors to match up this level. So you click on edit story, edit story. At default, Orion will always give each height or each floors the height of 33 meters. And from our design, we are taking 3.3 meters. So we're going to type in 300 because the units are in millimeters. You always pay attention to the unit. You understand? You're going to pay attention to the unit. So we include this, and the same, we're assuming that we have similar height for all the floors. We have similar height for all the floors, but in some occasion we have different. The higher the structure, the lower the height, of the structure. So in other design, you have to take such reference. So in this area, this simple design, we just want to make all the height the same, symmetrical, and our foundation design. Since we are taking two-story building, we are assuming that our soil is okay. So we are going to take our building depth to be 1.5, 1.5 meters at this region. We are assuming that the soil is perfect, there are good conditions, so we're going to say okay. So it's going to extrude the foundation, and it's going to balance anything. You can see that we are not having those extension anymore. It's now free. You can see, now that it is now free. You can see, even while we extend the slab, while we insert the slab, you can see that the slab has fit in with the beam. So in this design, by the time you have such design, it will be very, very iconic and very beautiful. You see, so you can also see what we have in here from our 3D, reflecting all we've done from the plan view. So this is pretty awesome. So in this regard, we are still going to do this because if you see the depth of this load, the depth of this beam will add 450 for the depth of this beam, because this beam is carrying a slab. The same thing here, But getting to this level, now we're not having a slab here. Since we're not having a slab, we're assuming we are taking this is our roof beam, So this is our roof beam. Since we have a roof beam, there's no need for us to have this massive, beam. We have to we have to reduce the height of this beam for we to, save cost for this building, you know. So what we're going to do is we're going to click. Don't forget, it is going to be on. Always look at your layer. Always look at the layer you're working on so that you don't click the other layer and you work on the other layer not knowing it. So you're not having repeated work, please. So what you're going to do, you look at our third layer, which is this layer, and the second layer is this, and this is our first floor layer, and this will be our ground level. This is your ground level. Although it is not identified here, but you should know that this is your ground level and our first floor level and your second floor level, and this is your roof level, which is our third floor. So what we're going to click on this, and when we right click, it's going to say is summary table. So we're going to look at the summary table for all the depth of the beam. We have the properties of the beam at this summary level. So what do? We're going to look at this is the width of our beam, and eccentricity, and we're going to look at the depth of it. So 450, we're going to click on this. We want to change. If you do this, if you go by changes, it's going to show you various depth. You can click this and it will be okay. Or you click the next one and you type. You can decide to type three, you know, 300. I want this to be like, I want this to take a foot, want a foot, a foot or 12 inches, as the case may be, for the depth of this beam, because I want to reduce the cost. So including this, for you to do this, you don't want to be doing one. You're going to kill your whole time because you have various, various beam. So what we're going to do is to take one. We're going to click on this one. Click on this, this spot here on this row, on this column. So you click here, it's going to show you this dark. If you click, it's going to show you this dark column here on the height. So we're taking the bottom. So working on the bottom, you click this button, you go to column otherwise edit. You click on column otherwise edit, you take the same, 300, and you click, that is 300 millimeters. So it's going to change all of them at the same time. And you can see that motion that it has reduced them from what we have here. So changing it, you can also change it to anything, any depth of yours. If you have similar design, you have different design, and maybe sometimes you might have a very longer span at your roof level. So when you have a longer span at your roof level, it is advised that you note of the span take note of the span and look for a satisfying depth to befit the span for the roof. It mustn't reduce to this level. So everything you're going to do has to depend on the kind of structure you are doing. So you must have to consider that depending on the type of structure. But since we are looking at this simple structure, we just have to stick to this dimension. You can see. So now we are done with our structural model. You can see everything is perfect. You can check, check all your detail. Check all your detail. Now, since you're doing your roof, it is very easy. You can still come here and take away this bar, but I think you should just leave it the way it is. So we can go and run our analysis right now. So we're going to our plan. Let's go to the plan view. Before we run our analysis, there's something I want to take to your notice. You know, having a structures like this, it is preferred that we are going to hinge this building. Now, hinging this building means you are trying to tension the end position of the beam, because this is a straight beam. This is a straight beam. There's an effect when your beam is running throughout a span. At the end of it, there are things, there's what they call a bulb. A bulb has to be introduced in your end-to-end beams. So I'll be explaining, the effect of or more effect of this engine on our detail template or on other video that I'll be showing on site. So for the purpose of this design, we are going to hinge our beam on both end. We are going to consider both end. So when we do this, you click at this end. You're going to this end is called when you have two design. For example, let's take this. Let's assume that we're having this beam to be our panel. Just assume that we're taking only this beam as a reference. Now, in this beam, let's say this end. I'm looking at this end from this beam. From this beam, this end is called the I end, and this other end could be called the J end. This is called the J end, and this is the I end. So on the horizontal direction, now on the vertical direction, if you're also looking at it from the vertical direction, then this will be your J end and this will be your Y end. In a simple one, I always denote this by using a coordinate where you have your y and x direction, you have the negative and you have the positive. So I always take the positive x and y to be my j, and the negative x and y to be my I. Always use that. So you can see that this region now reflects as, this is the down part, shows as your I, and the upper part will be your J. The same thing to the beam. So the same thing now, since we are cutting across this will be our I, and this will be our J end. On the vertical direction, this will be our all these this area, this point here will be our J end, and down here will be our I end. All right? Always consider it end to end. I'll only use this as a reference by telling you, but in this regard, we are going to take it from this point down to the end of this point because this beam is continued. So also on this other point, we're also going to look at that. So if you click on this beam, you're going to right click, then you go to what? Update beam end condition. So updating beam end condition, there are other conditions where it says no beam hinge. So no beam hinge now, that is the state where it is right now because we've not hinged. So both hinge means you want to hinge both side of it. Maybe when you are having just one beam, a simple supported beam at a particular area. So that simple supported beam, you have to hinge both end, because it's direct. But here we are having a continual beam. So when you're having a continual beam, what you need to do is to hinge one's end and the other end to be the J. Right? So right now, this end we are talking about, this end we are working on is the I end. So what do? We click on the I end. So click on the I and we say apply to select beam. So if you look at it, it has shown the bubble. This bubble shows that is the hinge, and it's going to reflect in your analysis and as well as your your detail bar. So we're going to exploit that later. So we're going to move down to the J end and also do the same thing. You click on the J end, you right click, and you go to what? Update beam end condition, and we're going to say J apply to all members. And if you apply, you're going to see the bubble bigger than the initial selection. Even while you escape, you can see that the hinge is still there, right? The hinge is still there. That's to show you that such beam is hinged already. So what we are going to do for it to be fast, you're going to click all the members that are having similar J. We're going to click on all the J's, like this beam is a continual beam. So we'll have J, or the J on this beam, on this one too, this other beam, we're having a J up or the J. So we're going to click on them. So when you click on one, you hold on your control, you click on the next one, you do the same thing, you do the same thing. Sorry, the cursor, the mouse is just fucking up. So you click the same thing, you analyze all your J. You can still do the same thing at your horizontal level. This is your J, your horizontal direction, that is your J. Here too, horizontal direction, this is our J. So we're trying to highlight all our J, the same thing here, this is our J. You click on the J. Since we are done with that, what we're going to do, we are done highlighting all the J, members. So we have another one here, you know. So okay, in doing this, you remove your hand from the shift, you right click, and you go to something update beam end, and you click on the J, also select, and it's going to, automatically fix all the J without you doing it one after the other. Similar thing will go on the I, the same thing. Press your control, you click all the I members, all the I beams that you want to hinge. You can see. I think you just do the same to all of them. You can see, and here too. Regardless that we don't have a column here, we still need to hinge. It's still part of the guide. It's still part of our hinge guide. So we have all of them highlighted. So remove your hand from the control, you press you right click, and you go down to the eye, and you hinge eye, and you know you said allow apply. So applying that, you can see that that take effect on all the members in the eye. you know so this was not infected, so we click on this, right click, and we'll go back, and it says eye apply. So you can see now that is all showing, and there is one here. You can see this two is what is simply supported on both column, even this too. So we can click on this, or press our control so that we can highlight both beams. So we've highlighted both beams, you right click in this direction. Since they are simply supported, what do? We're going to hinge both direction. Right? We're going to hinge both direction since they are not continue, right? So we're going to say hinge both direction. So we'll click on this and we'll apply. You can see it's hinging this spot and it's hinging this spot. You can see. So we're done with that engine. So you're going to reflect this on all the floor. You're going to reflect this on all other floor. So it's advised that you do this before you generate. So it's going to affect all the floors. So for that, I'm going to generate this before I'm going to run the analysis. So now we've come to the final point after running our model. So let's go to the building analysis such that we can run our analysis.